All right, so here we're going to be talking about relations and functions. So a relation is any set of ordered pairs, so I'm really just going to make up a random set of ordered pairs. That's a relation. It's just a random set of x, y combinations. That's all a relation really is. That's not very specific, but a function is a specific type of relation where it, again, is a set of ordered pairs, but it follows a function, a specific rule. And I like the visual of a function machine. You take some sort of input, you put it through the function machine, something happens to it, and it comes out as an output as something different than what it started as. And that function machine does the same thing each time. That's really the important thing about a function. Every x value has a unique y value. So let's say my function machine just added 5 each time. So whatever my input is, it comes out 5 higher than it was. So let's say my input was 1, it would come out as 6. My input was 7, it would come out as 12. My input was 100, it would come out as 105. I take some number and add 5 to it, it comes out as that output of here, 6. The same thing has to happen each time. That's really what this means. Every x value, whatever x value I plug in, comes out with the same value, a unique y value each time. So anytime I put 100 through this function machine, it should come out the same way. It will always come out as 105 because all I'm really doing is following that rule. That function is adding 5, so it happens the exact same way each time. That's all this rule is really saying. Every x value has a unique y value. So when I describe the difference between a function and a relation, really all functions are relations. Everything that you could describe with a function is a relation, but there are some relations that are not functions. So here are some examples. So this is a function because every single number, this 1 only goes to one number over here. It only goes to 3. It doesn't somehow randomly come out as something else. If it's going through that function machine, it should come out the same way each time that comes out as a 1. This is not a function because 9 is going to 3, and then sometimes it's also going to negative 3. That is not a function because it's not following the same rule each time. Same thing here. 3 is going to 5, and 3 is going to 6. That is not a function because 3 should follow the same rule each time. This is okay. So I'm allowed to have two lines come at this. Negative 2 goes to 4, and 2 goes to 4. It's not breaking its own rule. It's following the same thing each time. They just happen to be landing in the same spot. So that one's okay. That one's okay. These two are not functions. The easiest way to see this is just listing out my x's and y values. If these numbers are all different, that means that we have a function. If they all are different, as long as it's not the exact same point. So actually I could add this number. If that's the exact same, then that actually remains a function. But really, as long as I'm looking at different points, if I have all different x values, that's a function. If I have two x values that repeat and go to different numbers, that one goes to 12, this one goes to 15. If that's following a rule, that's not a very good rule because it happens differently at different times. That is not a function. Same thing here. 5 goes to 18, and 5 goes to 21. The rule should be intact. 5 should go to 15 each time if it's going to be a rule.